This is the tutorial on review 5.1, which is systems of equations by graphing and substitution. So let's go ahead and solve one by graphing here. And when we do that, what we're going to end up trying to do first is modify these equations to put them in slope-intercept form. It makes it a little bit easier to graph. So I'm going to go ahead and move this x term to the other side. In order to do that, I have to subtract an x term from both sides of that equals sign. So I'm going to subtract x from this side, subtract x from this side. And so my new equation is this, negative y equals, and then I'm going to write the x term first, negative x plus 7. So I'm going to divide by a negative 1, and what that'll do is it'll get rid of that negative sign in front of y, so y is by itself. So I've got y equals x minus 7, and that's going to be my first equation I'm going to graph. In order to get y by itself here, I'm going to just subtract that 5/10 x from both sides. And so typically when I am graphing in this slope-intercept form, which I'm going to be doing here, I'm going to end up thinking of the slope as a fraction, and it'll be easier to graph it that way. So notice what I've got here, y equals negative 0.5x plus 5, because I had to subtract that 5/10 from both sides. But I'm going to modify that into the fraction form, which would be negative 1/2 x plus 5. So I'm going to graph these two lines, and when I look at this one here, the 7, I have to go down 7 spaces. I can't quite fit that on my graph that I've got, because I've got 1, 2, 3, 4, 5 lines going down. 1, 2, 3, 4, 5. So what I'm going to do is I'm going to go by 2's. So I'm going to call this one 2, 4, 6, 8, and so on. And then down here I'll go, well, just write them going up, 2, 4, 6, and 8. That way I can fit 7 on there. So knowing that these are going by 2's, the negative side would go by 2's as well. So that's 2, 4, 6, 7 is going to end up being right here. And so that is down 7 spaces right there for that. Negative 7 represents the y-intercept. It's where the graph crosses that y-axis. So I'm going to use the slope now. Now notice that there's no number out in front of x, so the slope is 1 to 1 in this case. And so what that means is I'm going to go up 1 space and over 1 space. And so since I'm between lines, that's where I'm going to end up going. And so that's kind of what that line ends up looking like there. And I'll go ahead and take a look at the next one. So I can go ahead and draw the line between those if I wanted to, noticing that the line goes right by those points, and we'll move on to the next one. And on this one, we have a positive 5 for the y-intercept. So again, we're in between two values, since it's an odd number, and in between 4 and 6 there, and we're going down 1 over 2. So down 1 whole space, and then over 2 spaces puts us there. Do that one more time, down 1 over 2, and you see that's where they're going to end up crossing at this point. And so that's what I'm looking for, is that value, whatever that ordered pair is, that's what the two lines share in common, this one point. Otherwise, all the points are different for the two graphs. And so let's figure out what that point is. And so this point is 8 spaces over and 1 space up, because a half space is just 1. So this point is 8, 1. That's where the two lines cross. That is this point right here. So let's check out another one. These two lines are already in the slope-intercept form, so we're going to go ahead and use the y-intercept. And noticing that I can fit 4 spaces down, so I'm going to just use a 1-to-1 graph here. So I'll go 4 spaces down and then use the slope. The slope is negative 1, so that means that I'm going to end up going down 1, but then over 1 to the right. So I've got a point there. I can also go the other way, up and then to the left. Gets me on that same line. So once I do that a few times, let's just draw some points there, and I can draw the line between those points, and then I'll move on to the next line. So the next line ends up having a positive 4 as the y-intercept, so it's up here, and this slope is 3 to 5, so I'm going up 3 spaces over 5, but I can't fit it there, so I'll go the other way. Down 3, 1, 2, 3 over 5, 1, 2, 3, 4, 5, so 3 over 5, this means positive 3 to 5 is also the same thing as negative 3 to negative 5. So that's why I can go down 3 and then 5 to the left, and that's the point where the two lines cross. So that's the point they have in common. This point is 5 spaces left, so negative 5, comma positive 1 in this case here. So that's what that point is. So that's graphing systems. We're looking for where the two lines cross. Now we're going to solve some by substitution. So graphing's great until you end up getting something that doesn't fit on a graph too well, and that's where we need another method. Substitution works this way. If I've got y equals an expression and y equals another expression, I can set the two equal to each other. Y equals 5x, so I can write 5x, put that in place of this y. So 5x equals 2x plus 3. So I can subtract that 2x from all sides. That leaves me at 3x equals 3. Divide by 3, and I got x is 1. So x is 1, so I can take that 1 and put it back in for one of these x's here. So y equals 5 times by 1, and I've got y is 5. So I know it works with this equation down here, because that's why I substituted into. And this point is 1, 5. But I'm going to check my answer. I'm going to plug it back into this equation, see if I get an identity. So I'm going to write 5 equals 2 times by 1 plus 3. And sure enough, 5 equals 2 plus 3 is 5, and I get an identity. So I know I'm right in this case. 1, 5 is the point where the two lines cross. So on this one, it's a little different because we've got x by itself, and this other one does not have x by itself. So I'm going to use substitution again. I'm going to put this expression that x is, which is 5y plus 3, in place of this x. So I'm going to rewrite 2 times by 5y plus 3, and then plus 4y equals negative 1. So I do some work, distribute that 2 over both those terms. So I got 10y plus 6 plus 4y equals negative 1. So I go ahead and collect some like terms, move that 6 back to the other side, and I've got negative 7 equals 14y. So when I do that division, I end up getting a fraction. This is not negative 2, this is negative 1/2. Notice how the number in the denominator is bigger than the number in the, or is at least the absolute value of it is bigger than the one in the numerator. And so I end up with a fraction. I substitute back in, and here's what I get. X equals 5 times by 1/2, negative 1/2 that is, and then plus 3. So I end up with negative 5/2 plus 3. Now, I'm going to rewrite 3 as 6 over 2. See, 6 divided by 2 is also 3. This way I can collect these two terms. And so I end up getting positive 1/2 for x. So let's check and make sure this is right. So I know it works in this equation, because that's the one I put it into. So let's try this other one. So I'm going to rewrite 2, but in place of x, I'm going to put down 1/2. And multiply those numbers, and then I'm going to write plus 4 times by, and then I write negative 1/2. And when I go ahead and multiply and then add, I should get negative 1. Let's see if it does work out here. So I go ahead and substitute or multiply. I get 2 times 1/2 makes 1. And the opposite of 1/2 times 4 makes negative 2, because I got one negative there. And when I go ahead and combine these two terms, it should make negative 1. That's what I get. So I got a true statement, so I know I'm right. And so I'll go ahead and write the answer as 1/2, comma, negative 1/2. So that's solving using substitution. Let's take a look at the last types of problems that we'll see, some word problems here. So here it says the cost C in dollars for care and maintenance of a horse and carriage is C equals 25x plus 1,000. So C is the cost. Let's underline that so we know what C represents. X is the number of rides. Let's underline that part. And R, we're supposed to write an equation for the revenue. So revenue is R in terms of the number of rides. So we want to find out how many rides are needed to break even. Break even means what the two lines share. So this is going to be where the cost equals the revenue. That's what we're going to try finding. So let's write that cost equation out. Cost is 25x plus 1,000. And the revenue equation is, and this says $35 per ride. That's what you make right there. So 35x. So we want to find when they break even. That's when the cost is equal to the revenue. So I'm going to take this 35x and put it in place of the cost, because I want those to equal. So I now have 35x plus, and that actually equals, 35x equals 25x plus 1,000. So I can go ahead and subtract that 25x from both sides. That leaves me with 10x is equal to 1,000. Dividing by 10 gives me my answer of x is 100. So it's 100 rides. 100 rides until the revenue revenue equals the cost. That's what it'll end up taking there. So on the next problem it says there are 64 students in drama club and a yearbook club, so 64 total in drama and yearbook. So we are going to probably find out the number of drama and yearbook students. Let's find out. The drama club has 10 more students than yearbook, and we're supposed to write in a system of linear equations to represent the situation and how many students are in drama and yearbook. So let's go ahead and define some variables. Let's say D equals the number in drama, and we'll say that Y equals the number in yearbook. So now we're going to go ahead and write two equations. So my first one is total. Okay, so a total means they add together to equal 64. So the number of drama students plus the number of yearbook students totals 64. That's the first equation. Now it gives us a comparison. Drama has. Okay, has is kind of like a word that helps us, or it tells us equals. Drama equals. See, I can substitute that word equals in place of has. Drama club equals 10 more students than yearbook club. Okay, so let's go ahead and write that. Drama equals 10 more students than yearbook. So yearbook plus 10 is going to be equal to the drama club because they have more. So now we can solve, and solving by substitution works pretty well here. So I'll go ahead and put that y plus 10 in place of d. And I rewrite this as y plus 10 plus y equals 64. Subtract that 10 from both sides. Subtract the 10, and you've got 2y equals 54. So I divide by 2, and we've got y equals 27. So let's go ahead and find out the other number of, we have the number of yearbook students. Drama students is 10 more. So right here, number of yearbook students plus 10, and that's going to give us 37. So there we have it. So the number of yearbook students, we'll say yearbook students equals, and we had 27 students there, and drama club, or drama students, we'll just say, equals 37. So notice that this is an ordered pair. If I was to graph these two lines, drama students and y for one of the axes and yearbook students for the other axis, this is where the two lines would cross at this exact value, 27, 37. So those are the types of problems that you're going to see on the homework. Good luck.